All right, cool. So today we're going to be talking about testing. So when you write code, you can write code and you can, like solve the problem that you're trying to solve. But usually when you do that, you kind of, you have a particular vision of what that problem is and what actually so what solution is actually required, and then in the real world, when people start using your code, you'll probably discover that there's all kinds of edge cases that you missed, and there are things that assumptions that you made that weren't quite accurate, and so on. So testing is a way of trying to cover those bases and make sure that your code is robust before you find out in production that everything's broken, that some assumption that you made is in fact incorrect. So if you guys look at the README for today, let me share my screen. Let me get rid of this. So the README for today talks about test-driven development. So I'm not going to go in to test-driven development specifically. It's kind of I'll explain what it is just so you're familiar, but it's a very peculiar way of approaching writing code. So test-driven development basically, so let me say the typical or the intuitive way of writing code is I have a function, let's say, linear search or something like that. So I have a problem, I solve it, I write a function, and then I write some tests that test the function, right? So I write my actual code, and then I write test code to make sure that works. Test-driven development basically flips that on its head. So instead of writing the actual code first and then the test code, you write the test code first, and that test code kind of serves as your blueprint, and you use tests as scaffolding to construct your actual code, and there are definitely some advantages to doing this, but that's the basic idea. So if you want to read more about that, you can. If you want to try it out, that's also fine. I'm not really gonna to do that, but the reason I even mention this at all is because testing is it is important, and you do have to do it, and no one wants to do it. So it's one of those things where if no one makes you do it, you're not going to do it. But in professional quality code, you are going to have lots and lots of tests. So it's depending on where you work, it's basically guaranteed that you're going to end up writing tests. Okay. So instead of kind of just talking about this, I prefer to kind of do this in code. So what we're going to do is, there's a dead link here, by the way, which will be refreshed at the end of this. So I'll push up something to a GitHub repo. So all the code that I'm writing, you guys can refer to later. Okay, so I'm here in my terminal.
Are we supposed to be seeing the terminal? Because I see a like a bash alias instruction web page.
Oh, that is odd.
I see like your Slack on the left.
Oh, I must be sorry. Must have shared the wrong screen here. Yes. Sorry about that.
Awesome, thanks.
So everything that I was saying made no sense when you were looking at the bash alias webpage. Okay. So here is the actual the curriculum. You can take a look at this later. Okay. So can you guys see my terminal? All right, cool. So I've got my terminal, and I want to start a new project. So this is going to be in JavaScript. You could do this, do the same thing in Python, but I'll just do it in JavaScript. So I'm here, I'm at some, at some place in my machine, and I want to create a new folder that my project is going to be in. Can someone walk me through what I would do?
Make directory, and then the name of it,
Okay.
space the name.
Okay. So we're gonna write FizzBuzz. Has anyone ever done this before?
Yes, long time ago.
Yeah. So I've actually been asked this question to solve this problem in 2 different interviews. So
Yeah, I have a quick question.
yes.
Can we follow along in our terminals, or is this just for showing us an example?
It's up to you. I would, yeah, it's kind of up to you. You can do whatever you feel is best. If you want to follow along, you can. I would say probably just kind of watch.
Okay, all right.
But yeah,
We're not gonna install anything. We're not gonna do anything different. Okay.
no.
Right.
Yeah, whatever you want to do in this code that we write will be available after the lecture. So if you feel like you'll learn better by coding along, feel free. If you feel like that'll be distracting, then don't. Okay, so did this command work? I did make dir FizzBuzz. I don't see any like congratulations, you've created a directory message.
Yeah, you didn't get an error, so you could do ls in
Okay.
directory and see if it. Yep, there you go.
Okay, cool. So that's there. So now that I've created this directory, I would like to open it in VS Code.
So do code FizzBuzz.
Okay. And if you have that command set up, that should work. Okay. So now I'm here. I have my, this is my project window. How do I access the terminal?
Terminal and then new terminal, I think. Or I get
Okay, I could do that. There's also a shortcut. It actually tells you right here, toggle terminal. So it's control and then tilde. I only use characters, but that will open this up. So I just want the regular terminal here. So I'm gonna zoom in a little bit. All right. So now I'm here and I would like to create a JavaScript file so I can start writing some JavaScript code.
Touch and then the file name.js.
Okay, so I can do that in the terminal here. I can do touch. And that'll show up. I could also, if I want to use the GUI here, I go here, click on a file, and then whatever file I want to give it, whatever name. So I'm just going to delete that. Okay, so now I have my FizzBuzz right here. Okay, cool. So, so this is something that you'll do lots and lots of times. Anytime you get a problem, whether it's these kind of somewhat canned problems you'll see in an interview, or a lot of the challenges that you'll be doing, or it's like a real world problem. You get something at your job. Hey, we want you to build this. We want you to fix this. Planning out what you're going to do before you just start doing it is important. So FizzBuzz, can someone explain to me what the actual problem is that we're trying to solve?
I think if I remember correctly, so if it's a multiple of a certain number, I think it was 5, you do fizz.
Okay.
If it were 3, you do buzz. If it were 5 and 3, you do FizzBuzz. Okay. I believe is kind of how the question was structured.
Okay, cool. So you kind of started, that's kind of like the middle part. What's the beginning part of the problem? So what am I starting with?
You have to count to 100 or some definite number.
Yeah, so I start with some number or number range. So we could, if we're designing this, we might want to ask, that might be a good question to ask. What are my inputs and what are my outputs? So what are my inputs? Do we always want to count to 100? Do we want the user to be able to determine what that number is? It could be variable. It could be, up to a certain number. So there's all kinds of variations. So how would we decide that? Well, in real life, we would talk to other people, talk to customers, talk to whoever knows this stuff, if anyone knows this stuff, and then we would arrive at something. So let's say for our purposes, let's say that we want the user to be able to give us that maximum number. So I'll just do so input. So an integer, and what am I going to output?
String,
Okay.
or actually isn't it an object?
Okay, so that's a great question. So what should our output be? So why string, why object?
I was thinking string as it was just gonna give you the number and then fizzbuzz, but I think we had to structure it as an object. So it'll do all the way from 0 to n, whatever the input was, the integer. And then it'll give you, like 1 is fizz, 2 is buzz, 3 is fizzbuzz, or whatever.
Okay, yeah, so there are a lot of different ways we could do that. So that's definitely an option. We could definitely do an object where the keys are the numbers and then the values are whatever transformation we want to execute on them. I think so yeah, I mean, there's no reason why we couldn't do that. It would just depend on, again, if this were the real world, you would probably have a better idea of what it should be. It wouldn't just be, you could do anything you want. Let's just say for our purposes that you have to output a string. But yeah, we could certainly do it differently. So we're going to input a string, which is going to be a number from, let's say, just some integer. It could be anything, and then a string. And all the stuff in between the input and the output is the logic of our program. So as James mentioned, we've got, you're going to check for if it's divisible by 3 and 5, check if it's divisible by 5 and 3, and so on. Okay, so let's do. Let me do a multi-line comment. Autofills helping me out here. Okay, so we're going to check. Let's just do 3. And I'll copy this. And then if it's divisible by 3, we're going to return what?
Is it fizz?
Okay. Yeah.
Yeah.
I think that's typical. It doesn't, doesn't really matter as long as it's consistent, but and then buzz. Okay. Okay, and then what if it's not any of these things?
You just output the number.
Okay. And then so here's the first, I guess, little quirk. what is the output going to be?
It's a string.
Should be a string.
Amount to string.
What's that?
Are you using toString function to make the number into a string?
Yeah. So we could make sure. So JavaScript, JavaScript will coerce. We'll basically convert the type for us under the hood, but we might not want that. That might cause problems. We might want to be explicit about that. Other languages, you do have to be explicit. You can't just say, I'm going to write a function and I'm going to return some kind of thing.
You might want to return a string array rather than just a string.
Okay, we could definitely also return a string array.
That you're gonna have to do. Yeah. I just remember doing this one, and I even feel like it's string array is what the output is. Sorry, I didn't mean to interrupt.
Sure. Yeah, that's fine. So yeah, there's lots of different ways to possibly do it. It's it's a made up problem and it's kind of open ended. So, but yeah, this choice is somewhat arbitrary. So I'm just gonna say that's what we're returning. It could be an array. It could be an object. So I'm just gonna say that here's the requirement, and that's just what we have to do. But yes, there's, we'll see. So we're gonna do one thing and then we'll play with it a little bit. So we're gonna probably end up doing something like that anyway. Okay. All right, so I think this is probably good. I think we have a pretty solid plan now, so we can start writing code. So I'm gonna get this going. I'm gonna write a function called buzz, and we know that it's going to take a number as an input, so I'm just going to call that num, and we know that it's going to return a string. So I'll just kind of leave that here as a placeholder, so I know that it's going to return a string. And now let's go ahead and fill in everything else.
Chad, are we counting up or counting down from the end number?
That's a great question. It's possible that we could do either. Kind of depends on the specific implementation. I would say the most straightforward thing to do is to start from a low number and go to a high number,
Okay.
which is actually, did we discuss where we're going to start?
No.
Yeah. So, as you're planning, planning is good, but there's often, you overlook something or you don't think about something. And when you go to implement it, it's like, oh, wait, you have to choose a starting point, right? You can't just, the code won't just magically know where to start. You have to tell it where to start. So where should we start?
0.
0? Yeah, we can start at 0. We could start at 1. So again, it's an arbitrary decision. I'm not sure. I think probably 1 would be the, humans typically start counting at 1. So we'll just start at 1. So let's say we want to start at 1 and go to whatever this number is. So what's the next step here?
Would you do a for loop to count from 1 to that number and create the key in the object?
Okay. So we can create a for loop to help us iterate from starting at 1 or whatever arbitrary number we want to begin with and going up to this number. I'm not sure that we're gonna need an object.
Okay.
Let's see. So now that we're doing it, I feel like I kind of messed up a little bit what I was doing by specifying a string. That's okay. Okay, so let's write a for loop that will help us iterate over. So for, and then we want to start at 1, right?
Mhm.
So let I equals 1. And then,
I is less than or equal to number
okay,
or num. Yep.
cool. So we've got this for loop, and now we can iterate over it. So let's say I'm going to, I'm going to tweak this a little bit. We could keep returning a string, but let's just say I just want to print out to the console all these things. So print, 1, then 2, then fizz, and so on. So let's just say, okay. So that'll make our code a little simpler, I think. So what's next here? Let me pick on someone who doesn't want to be called on. How
I have
about,
a quick question.
yeah,
Is there precedence on like 3 or 5? So if it's like divisible by, well, never mind, because if it's precedence by 3 and 5, then it's 15. Never mind.
no,
Answer my
okay, so
question.
that is a good question. So we have all of these, conditional, so we know that, if it's this, do that. Does order matter here?
Yes.
Okay,
Yeah.
so order matters. Is there maybe another way of expressing this?
You could do remainder. So either you can do an and statement, say if it's remainder 3 equals 0 and remainder 3 equals 5, or I guess you could just say remainder 15 equals 0.
Yeah, I was gonna say, I think if it's divisible by 15, it's the same as 3 and 5.
Okay, so that's another way. So not, maybe there's not much of a difference, but or 115. So yeah, so we could implement this either way. So this requires 2 checks. This just requires 1. So this might be slightly more efficient, but we'll talk about time complexity and stuff like that later. Okay. So we should check this first. Is that right?
Yeah.
Okay. So if so we'll just do it 15. We could do so what is this operator?
Modulus.
Okay.
Modulo.
And what's the result of this going to be?
Purple equals 0.
But what is the result of this going to be? So if num is 14.
1.
Yeah. Yeah, so it's just going to give us the remainder, and then so it's divisible by 15 evenly, then that means there's going to be no remainder. So it should be 0. Is this right?
We need the 3, don't we, to make sure?
Okay, so should we have 3 or 2 equal signs?
I always did 3 just to be safe.
So it
Okay,
explicitly is
For
0.
the explicit equals.
okay, so what's the difference? It seems like 3 is maybe somehow more intense or strict or something.
I think 3 is if it checks the type too. So if it's 2, it will be integer or string 0 would be equal. And if it's 3, it checks the type and makes sure it's string or integer.
Yeah, exactly. So 2 equal sign, basically JavaScript will do its usual freewheeling type coercion. And if you do 3 equals, it's gonna check the type and the value. So it's not gonna try to coerce a type. So you give it a string 0, it's not gonna say maybe you meant an actual integer 0. Okay. So here we go. And then if it's that, so all right, and then what? How about let me pick on someone who really doesn't want to do it. How about Aaron? Haven't heard from you yet.
Hey.
Hey. So
Right.
here we are. So we've got our first conditional FizzBuzz. So what's the next condition we should check?
So then we want to do else if num is num modulus I guess the 3.
Okay, so we have so we've done this one, so we have, I guess, 3 more options. So we could if it's divisible by 3, divisible by 5, or basically none of the above.
Yeah, if the num modulus 3 equals 0, then console.log fizz.
Okay. What if we get a number like, I'm trying to think of, I'm not sure that this part, would it matter? Maybe it doesn't matter, the order here.
Well, like for example, if you run 30 through this, you're going to hit true on the first if conditional, and then if you have 3 in the next, you're going to hit it again. So you need either an and statement, I guess, or
Okay,
else.
good. So there's one question about the order here. Does it matter if is it basically order agnostic? If you put the divisible by 5, divisible by 3. And the other question is,
If it was both, it would already be fizzbuzz.
how's that?
If it was divisible by 3 and 5, it would already be fizzbuzz.
Yeah, exactly. So that's maybe something that, that's like a problem. That's like basically a math problem. So we might have to figure that out, or maybe we might have to write a lot of tests to make sure that we're doing that right. Maybe it matters, maybe the order matters, maybe it doesn't. The other thing is, so Aaron, you said else if. So why did you say else if?
I mean, you could just do if as well, but then it's checking, it's going to check the 15, and then it's also going to check the 3 instead of just console.logging the 15, right?
Exactly. So if we were to just do if here, let's say we have 30 is the number. Let me just add this.
It's going to print both.
Yeah. So for 30, it would be fizzbuzz and fizz. So we want to keep these basically exclusive. So it's not going to try else if.
Hey, Chad, should we throw a continue after the if num modulo 15 is 0 statement?
So that's a good question. We actually, I don't think we need to do that. So we could, if this were like a whole bunch of expensive checks, you might just want to say, okay, once this one hits, you don't need to do all the other ones. But the else, if as long as we make it like else if, that's basically what it's doing. So we could do ifs, just regular ifs, and then do continue. So as soon as you hit this, like jump back into the for loop. So continue, by the way, probably something you should avoid in general. It's kind of it's what they call a code smell. So if you have continue in your code, like you might want to think about, maybe there's a better way to do this. Yeah, so that would kind of be an alternative to using else if.
Yeah,
I didn't know that about continue. Thank you.
Can I ask something? I think maybe we want to do I modulus 15 and I check the I because that's what changes, not none.
Yeah.
Okay, good. Yeah, so I think we found a bug, right? So we could leave this and then write some tests, and that would probably point us in the right direction, or you could just go ahead and, yeah, so I. Good. So I'll just go ahead and finish. So else if I 5. Buzz. And then, so for this last one, so a couple questions here. Again, I'm going to skip this part, but in a real application, what if someone gives us a string? What if someone passes in hello world to our function? How are we going to handle that? Are we going to? So we basically want to make sure that we're actually getting an integer and not a float or a string or an object or anything else. And so we might want to do some kind of check. In other languages, you wouldn't have to worry about that in stricter with a stricter type system. But in JavaScript, you might have to worry about that. But we're going to ignore that, and we'll just say we're assuming that we can only get integers, which is just an assumption we're making for simplicity. So, and then what are we going to log?
Num.
I.
Yeah.
Yeah, we're going to log I. So implicitly, this is going to get converted into a string. We could make that explicit by string.
I have 2 quick questions.
Sure.
So first, does JavaScript need semicolons at the end of statements?
No, you don't have to do it. I think the compiler will automatically insert those, but you don't need them unless you're doing something like, for example, like here where you're doing multiple statements on one line.
Okay. And then my second one is, so if you put in a string, does JavaScript do catch throws or does it use something else?
Yeah, so there's try, what was it, try and accept or try catch. We'll worry about that later. Yeah, I think it's catch, and it might take an error here. Yeah, so there are things you can do to handle errors, basically, but we're not going to worry about that right now.
Okay, great.
Yeah, that is something in real application that you have to worry about. Okay, so I think we should be good here. So let's we'll just try it out. Actually, I don't need the console log it. How do I run this?
The name of the file.
Okay.
Node, fizzbuzz.
Yeah, node, and then the name. Sorry.
Yeah.
Without the JS.
I'm not sure actually. Let's see. I guess it will accept it without the extension. But you should probably include the extension because you might have potentially another file, fizzbuzz.py or something like that. Okay, so 1, 2 fizz, 4 buzz. That looks right to me. Are we pretty confident that this is right?
Let's try
Like to get up to 15, check 15.
Okay. Actually, I'll just so 15. So looks 78 fizz, buzz is 10, 11, 12 is fizz. Yep. So 3 and then 15 fizz buzz.
Chad, just to be safe, I think we should do it up to 1 million.
Okay, yeah. That's
Yeah, we got all day.
I'm certain. I think my computer's slowing down.
It's a RAM battle now.
Yeah. I'll go ahead and stop that. But yeah, so good point. So we've got some tests. How do we know that this really works? So we'll try and figure this out. Let's take a 10-minute break and we'll come back. And then we're going to look at how we can approach this problem through a slightly different lens in terms of making it testable. So take 10 minutes and we'll come back. All right, so we've got our FizzBuzz function here. And, let's say, we're at work and we got the ticket and so we're like, okay, boss, all done with the FizzBuzz function. Here you go. And our boss is like, okay, well, we trust you. We trust that you, that you know what you're doing and that you've tested all the different things and blah, blah, blah. Is that how it works? I mean, maybe you don't have experience, but that's definitely not how it works. So what you're gonna want is, some degree of certainty. You wanna have as much certainty as possible within reason that this actually does what it's supposed to do. So how do we do that? And not only do we want that certainty, but we want it documented. So I could just say, I'm running on my local machine here. And so I developed this and I tested, I tested all the results and I even tested up to 1 million. And I could see that, it works. So that's good. The problem with that is that one, you're just relying on some guy who said that he did some stuff and maybe it works, maybe it doesn't. Maybe his local environment is set up differently. There's all kinds of possible variations. So what you want is something that's like clear and consistent and documented so that everyone can see it and it works the same for everyone. And if there are questions, it can be addressed there. So you want some way basically to record these tests. So one thing we could do, a kind of poor man's version of this is to say, like, check the value. So we could do FizzBuzz 30. So if I were to assign this to a variable, what is FizzBuzz 30? James, if you're talking, you're muted.
Oh, sorry. I said it's the function FizzBuzz with 30 as the argument.
Okay, so that's, yeah. That's kind of right. So could anyone maybe be more specific? What is FizzBuzz 30 going to be?
The output of FizzBuzz with 30 fed in as the argument.
Yeah. So depending on what you mean by output. So what do you mean by output?
I guess whatever it returns.
Yes. So to be specific, FizzBuzz 30 is whatever this call to FizzBuzz returns. So it is the return value of this call to FizzBuzz. So what is the return value of this call to FizzBuzz?
Undefined?
Yes. Why is it undefined? Because we have a whole bunch of stuff printed out to the terminal.
Because we didn't have a return, we just console log.
Sorry, can you say that again?
Oh, because we just did a console.log, we didn't return.
Right. Yeah. So I kind of initially set this up. I wanted to make this example and I was not thinking, so I had a return a string initially, but yes. So right now we're not returning anything. And so a function that doesn't return anything returns in JavaScript undefined. So we could do this. And that's basically the same thing. So implicitly, JavaScript, the compiler or whatever is going to insert this implicitly if we don't supply a return value. So how can we test this? So I could do something like, I think, is this right? Search, let's see. We don't have that. Is there a cert built in JavaScript? I forget. Yeah, I'm gonna have to look that up. I'm gonna look that up real quick. Console.cert. This is just. Let's try that. Okay. This is one way that we could do this. So, I could write some tests. So for example, fizzbuzz30, the problem is that this is going to be undefined, right? So I can do fizzbuzz30 is undefined. And what is fizzbuzz40? Also undefined. And what is fizzbuzz1? That's also undefined. So the problem is, like, this function is doing a bunch of stuff, but we can't really directly access it. So how could we possibly test this? I mean, how could we test this in a way that's kind of self-documenting, that doesn't require someone to run it and then look at the terminal output and say, okay, well, yes, 15 should be fizzbuzz and so on. Well, the answer is it's basically impossible to do. There are a couple of tricks, but it's basically impossible to do. And it's impossible to do because this function is just doing side effects. So a side effect is something like printing to the console. It's interacting with the world outside of itself. So this function, if you think of it as its own little enclosed space or its own little world, ideally, you want functions to only do stuff within themselves. So I give it something, and then it returns a predictable output based on what I give it. Here, it's just returning undefined, which I guess in a sense is predictable, but it's what we care about is all the other stuff that it's doing, which is, might vary depending on the environment. Maybe it works on my machine, but not on yours, or there's some issue with my computer, and so console log doesn't work. So this is interacting with other stuff. So it's doing stuff outside of itself. So this function, and when functions do stuff outside of themselves, when they do have side effects, it's very, very difficult to test side effects. So side effects include things like writing to the console, making a network request, writing something to a database, reading something from a file. So something that's like, and of course, all computer programs need side effects because they all do stuff in the world. But we basically want to minimize and kind of control and isolate side effects. So the way we've written it, this may work, but it's not really testable. And so that's probably not going to be acceptable. So what we're going to do now is we're going to rewrite fizzbuzz in a way that it's actually testable. And to do that, in part, we're going to use a test tool.
Sorry, can you explain the assert function? Because I remember reading about it. I can't remember what it does. It just gives true or false.
Yeah, it should. It accepts a Boolean in this case. So this will be evaluated to either true or false. So, and if it's true, I think it looks like it does nothing. And if it's false, then it looks like it's just printing in the console. So there are other languages that they would do. You might throw an error or something like that, but looks like this is just.
So there we're just demonstrating that it doesn't return anything. Is that what we're trying to do?
Yeah.
Okay.
Yeah. So I'm just showing you how you could start to write or start to think about writing tests.
Yeah.
So this is like, we could do stuff like this in the code or in some other isolated part of the code and say, look, this function does what it's supposed to. Here are some tests. I'm asserting that this is this and this is that and so on. But this is kind of like a poor man's testing. So we're going to look at testing library. Just so there are a whole bunch of testing libraries. So I'm not saying that this is the best one or anything, but this is this is a popular one. It also kind of comes with React by default, so we'll be doing stuff in React. So we'll take a look at this. It's also an introduction to using third-party modules. So Jest is not Jest is a testing framework. It's not a part of JavaScript or Node or anything like that. So this is just a bunch of code that other people have written, and we can use it. So I'm going to go here, click on Docs, and I can see it'll install Jest using your favorite package manager. So we don't have, we have Node installed and everything, but Jest is not a part of that. So this is a third-party thing, so we need to explicitly download it in order to use it. But in order to get this working, I could just, install it potentially, but what we're actually going to want to do is set up a Node project. So if we set up a project that enables us, we get some tools for basically managing some complexity, so we don't have to do it all ourselves. When we do that, if you're setting up a Git project, you just do git init, right? So git init will do all of its magic, kind of set everything up so you can start using Git. npm init will do the same thing. So npm init. And when I run npm init, I'm basically going to get like a form that I have to fill out. So I'm going to get some, it's going to ask me some questions in the console, and I can fill out those answers. And at the end, it's going to generate a form, basically. So we'll see what that looks like. I'm just going to press enter and do the defaults because this is a throwaway thing. But package name, version, description. Yes. Okay, and then you can see at the end of that, I get this was added. So I get this package.json file. And we don't need to worry too much about this, but this is basically documenting some aspects of our code. So this is a way of documenting configuration and dependencies and other things like that. So we don't care about any of this because we're not really publishing this for anyone else. Okay, so now we have our project set up so we can start downloading third-party dependencies. So we can go back here, and now we can actually do npm install save dev jest. So I'm going to run that. And this save dev flag, this is not strictly necessary, but we'll see when you're setting up projects, you're going to have basically let's say real dependencies or just dependencies for your actual code, and then test dependencies or development dependencies that you just need like to run tests or to run things locally on your machine. But when you actually push it to production, you don't need that stuff. Okay, so I'm gonna execute that. It's gonna install everything, and we'll see what happens. Okay, So you can see that a couple things have happened. One, I get this node modules directory, which has a whole bunch of stuff in it. Oh, we'll take a look at that in a sec. And the package.json, it actually changed. So this got added. So there's a new field called dev dependencies. And by the way, let me just say that package.json, so this is the JSON file. You may have heard of JSON, JavaScript object notation. It's basically like an object in JavaScript. So it's just a specification, and this is commonly how data gets sent. So if you want to send data from like my machine to a server, or from a server to my machine, you almost always will do it in JSON. So it's just kind of a typical standard. Okay, and we'll work with JSON more, but you don't really need to worry about it. So we got this dev dependencies, and it's Jest. So we installed Jest. It says right here, and then this is the version. So this caret in the front, this up arrow basically means this project can use anything, any version of Jest that's above this, or this or above 29.1.2. And then the package lock, this is a very, very big file, and you never really want to edit this by hand. But this actually shows all of the full dependency chain. So for my project, let's just say I've got my humble little project here, and I just need to use Jest. So my project depends on Jest. Well, guess what? Jest depends on a bunch of other things. And those things depend on a whole bunch of other things, and so on and so on. So you can get very, very large dependency chains. And this package lock is basically the full and complete accounting of all of the direct and indirect dependencies of your project. So this is, we don't need to worry about this, but so here's something that it needs. Here's the version, here's the shop. This also has dependencies, and so on and so forth. So you don't need to worry about this, but just to show you. And then node modules, this actually contains all of the code that's in the package lock.json. So it's literally like doing git clone, but it's doing git clone for every one of these things. So it's just downloading. This is just JavaScript code. You could have written this and pushed it up to npm, and then you could install it. So, this is a small thing. There's not a whole lot going on here. This is a pretty small package. And then others are much, much bigger. I don't know. These are, but anyway, you should never really have to modify package lock or node modules. The only thing you need to modify potentially is this. Okay. So now we have our package lock, and we know that we're going to use Jest to test things. So let's go back to the documentation and see how we can use it. By the way, reading documentation is going to be a huge part of your life as a programmer. So some documentation is really good, some of it is terrible, some of it's non-existent, some of it's out of date. So navigating all that is part of the fun. This documentation is fortunately pretty good. So it tells us to get started, blah, blah, blah. We can write a test case. So here is, application code. So this is like the real code. This is like our FizzBuzz right here. So we write this function, and then we write another file called something.test.js. And then there's some tests. So let's just go ahead and follow the README. That's usually good. And then we can kind of tweak what we have based on that. So I'm going to create a sum.js file, which I can do in the console, or I can do up here. I'll do it up here this time. So sum.js, paste that. And I go back here and I create a sum.test.js. I'll do this on terminal. Okay, same difference. I'll paste that in. Okay, so now I have, this is our example. So I have my like application code right here. Don't worry about the export. This is just the JavaScript thing. We have to explicitly export things, and then you explicitly import them, and then you can use them in another file. And here's the code. So this looks a little intimidating. There's lots of functions going on here, but let's go back to the documentation. So the last part we need is to add the following section to your package.json. So scripts and test. So let's take a look at that, package.json, scripts and test. So by default, we get this. Does anyone know what this is?
It's just gonna print out, there's no, there's an error, there's no test.
Yeah, it's just like it's a shell command. So I could actually just run this directly in my terminal.
And it'll just say error, no test specified.
Yeah, I shouldn't have done that, but. Okay, I can do that. I can also. So Jess tells me do this. So this is basically when I say npm run test, whatever script I put in here is going to get run. So npm run test. It's just going to execute this. So instead of my own thing, I'm going to put Jest, sorry. And Jest will kind of take over from there. So Jest is going to manage all of this stuff for us. That's one of the benefits of using a testing framework. So if I run npm run test, it's actually Jest is going to take over and it's going to do all of its stuff. So it is automatically going to look for tests in the code, and it's going to do that based on the name of the file that you give it, and then it's gonna run them. And it gives us some nice colorful output. So pass, and we can see here's one of the tests. There's only one test, but adds 1 + 1 = 3, and it took 2 milliseconds to run. And we get so we can see here that's this description. So let's take a look real quick at. So we don't know anything about this package. We've never seen it before. We just kind of have gotten this far. So let's try and figure out what we can know about this. So what do we know about test?
It's a function.
It is, okay, good, it's a function. And anytime we think about functions, you should ask yourself 2 questions. What is the input and what is the output?
It looks like the input is another function.
Okay, so how many things does test take as input? How many parameters does it have?
2.
Okay, so what's the first parameter?
A string.
Okay, it's a string. And we could maybe, since we ran the test, we can see it looks like we can make an educated guess. This is probably like just a description of the test. So if we were to kind of mock up a signature of test, we could say, we maybe call this description. And then we have another parameter, and that parameter is a function. So where does that function start and end?
With those curly braces.
Yeah. So this is actually the entire second parameter. So we can call this, maybe like we're not sure, but let's say So this test, we know something about it, even though we've never seen it before. We know that it takes a string, which is probably a description of the test, and then it's gonna take a callback function. So it takes another function. It's a function that takes another function. So what is there a term for a function that takes another function?
Is it higher order function? Is that what it's called?
Yeah. So that's a higher order function. Function that takes a function in or that returns another function. You can also return a function from a function. So this is a test is a higher order function. So we know that about test. It's a higher order function. It takes in two parameters. One of them is a string and the other one is a callback function. And this function, so this is an anonymous function. Doesn't have a name. It's an arrow function. It doesn't take any parameters. So again, we can learn something. So this is, it takes a function, which this callback function, then we can kind of say, what is this callback function? So it takes no parameters, and maybe it's not obvious what it returns, but it returns whatever this is. And we can know something. So that looks like this is yet another function which accepts something. So sum 1, 2, this is calling our source code here. So we know that this is going to return something. So this is going to get evaluated, sum 1, 2. Let's just say it equals 3. And then expect is a function which takes this value, 3 in this case. And then there's a .2b on it. So what do we know about the this expect function right here? What kind of thing does it return?
Probably a Boolean.
Boolean, yeah. It's gonna be true or false.
Yeah.
Is that an object?
Yes. So why is it an object?
Do you have a key and you have a property there?
Yeah.
Yeah.
So this function has a .2b. This function has a method on it. So if something has a method on it, it's an object. So this function actually returns an object, and that object has a method on it called toBe. And then toBe gets evaluated, and that probably returns a Boolean, but maybe we're not sure. So there are, even though we've never seen this library before, we've never seen this code before, we can like kind of get a pretty good picture, at least an outline of what it's doing. So some things we can know for sure, like this takes two parameters, one is a string and one is a function, and so on. There are things we can kind of make educated guesses about, and so on. So we can form like some kind of picture about what's going on rather than just being like, oh, I have no idea what this is. It's just a whole bunch of nonsense. Okay, so we have, some basic idea of what this is now. So let's kind of return to our original problem. So we have this FizzBuzz, we wrote it, we realized, hey, this is not testable. We need to write some tests. So we go looking for, rather than, trying to write a bunch of testing, framework kind of stuff ourselves, we do a search on the internet for JavaScript testing framework. We found Jest right here. And so we looked at the documentation, and now we're pretty sure that we can at least get started using it. So I'm going to go back to, I'm going to rename okay, and I'm just going to follow the pattern here. So I'm going to write a function, and then I can export it, and then I can write some tests. Okay, so first thing, let me open up this on the side. All right. So we have our fizz buzz. So we need to make this testable. We need to basically, we want to isolate side effects. So we still want to take in a number as input ultimately, and we still want to log the output as a, log the output to the console. So the functionality hasn't changed. We just need to refactor it so that we can kind of get at some of the internal components. We can test them and make sure that everything is working. So if I were going to break this up into a more testable subproblems, the thing I need to worry about is I want to return a value. I want every function to return a meaningful value. And I want to write functions that are pure. So this is basically like a technical concept. So purity means that the function takes an input, and every time I give it an input, it returns the same output. So for example, sum, if I copy this, sum is a pure function. So I can call sum with 5. I can assign this to a value. All right, I guess. I can do this, and it doesn't matter how many times I call sum with 5 and 2, it's always going to return 7. It's always going to return 7. It doesn't matter what else is happening in the world. It doesn't matter if the network is down. It doesn't matter if there's, a bug in the database. It doesn't matter, what other external variables are at that point. Whatever I give it, it's always going to return the same value every single time. And so a pure function could basically be replaced by a lookup table. So instead of calling a function with 5 and 2, I could just have a table where I look up the inputs 5 and 2, and then I, move over, and then I see, oh, it's 7. So we don't use a lookup table because that would be really verbose, and we'd have to, create an entry for every possible thing. So we don't actually use tables. So we're not really going to talk about this, but there are tricks you can use for caching results, which basically is like a partial lookup table. So you can that's another benefit of using pure functions, is that it's easy to cache values because it's always going to be the same. Okay, so we have a function. So we're gonna rewrite fizzbuzz, and we need to kind of isolate it into subcomponents, and we want all of those components to be functions that take a value and always return the same output given the same input. So I would say one thing we can do is, we know we're going to get an input as a number. So I think we should take an input as a number and return an array of all of the numbers that we're going to want to go over. So if we get 10, we want to return an array of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's see. So function, I'll just give it a name. So return array of nums. Okay, so this function is going to take in num, and it's going to return an array of nums. Another function we could write is a function that takes this array of nums, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then returns, let's say, a transformed array. So instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's 1, 2 fizz, and so on. I'll call it a fizz buzz array, which is going to be an array of strings. And then I can have another function which turns this array into a string. and another function which is gonna actually console log. So we could also add another function, I think, in between these that is actually going to have our logic here. So we'll have another function, maybe like a helper function or something, that is going to take in a single number and return either, fizz buzz, or the number turned into a string. Let's call this return transformed. So I'm going to try to move a little quicker because we've been here for a while. So I'm just going to go ahead and implement some of these. So return array of nums. So I'm going to write these functions in a slightly different way just to give you some exposure. So I'm just going to write them as anonymous functions. So I'm going to do const array of nums. So this is an anonymous function. I'm assigning it to this variable, and this is going to take in a parameter, which is going to be that num, same one here. And what that is going to do is it's going to generate that list. So we're basically going to have this same logic here. So I'm going to, there's other ways of doing this, but I'll do this for the for loop. So we'll do call it. We'll start with an empty array. I'm going to loop over it. So for, just like we did, let I equal 1. I is less than or equal to num I plus plus. And I'm going to append the number to generated array. So generated array dot push, and I'll push I. Okay. So now I'm just gonna real quickly, just like a sanity check, basically. I'm gonna do console.log array of nums. I'm gonna pass it in 10. So I'm expecting an array 1 to 10. So node is buzz testable, and I get undefined. So why do I have undefined here?
No return.
Yeah, exactly. So I am creating this array, but I neglected to return it. So I'm creating the array, and then I didn't specify a return value, so it returns undefined. So I can generate an array. And that looks right. So I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now I have a pure function. So I give it a number and it returns an array, and it doesn't matter, it should always give me an array that looks like this given this input. So now I'm going to go over and I'm going to create a test that's going to test that. So I go over here and I'm going to call it is buzz testable.test.js. Okay, and then I can see from the documentation. So I'm gonna have to export this. So module.exports. Where am I now? So is that? Put that bottom. Yeah, I wouldn't worry about this right now, but we'll just do this. So we're explicitly saying this is available for export, and then in the test, which is over here, we're going to import that. So I'm going to export it like this. And then I'm just going to give it the file path here. So this is fizzbuzz. So, and I, even if I don't know exactly what's going on here, I can use I can work from the template that I was given here. So I'm, here's my function that I'm importing, and I have to import it here and give it a name, and then I can use it here in the test code. I'm going to copy this, and I'm going to go to my version. I'm going to paste this in, and then I'm going to kind of replace, so array of nums. And I know that this takes a number, and then it's going to return an array. So in this case, it should be with 1. It's a pretty simple test case. And I can rename my test. So array of nums returns something like that. Okay, so I have a test, and assuming that I've set up everything, this should work. So I'm just gonna go ahead and delete this for now. And I'm gonna run npm run test. Okay, so this test failed, which is fine. It can actually be a good sign. So array of nums return blah blah. So this fails, and then I get some output. So it says type error. Array of nums is not a function. So I have an issue with my export. So if I take a look at that, let's see here. Fizzbuzz testable. So I'm just going to get rid of this for now. There's some tricks. So the export stuff is always a little wonky for me, but let's give this a go. Yeah, I think I'm going to export this, and then I import it. I could do default, but I'm going to end up adding more. Sorry, I always forget the syntax here. I'll figure that out. Let's see. About exports. Right. Comment that out. It's not a function, so I'm going to do
Do you need to require it from Fizzbuzz testables?
Oh yeah, sorry, man. Thank you. Thank you very much. All right, so this shouldn't have to do this stuff now. Okay. Okay, so thank you very much. Yeah, I will definitely make mistakes, so please point them out if you see them. Okay, so this is now running and it's failing, but it's not getting that error. So can someone explain to me why this is failing?
Oh, it wants the triple equal instead of to be, right?
Okay, yeah, so there's something going on with the equality checking.
Does it want you to replace the to be method with strict equal method?
Yeah, so it is, it does want me to do that. So why? So let's say we don't know anything about this. So what are the two things that I'm comparing?
Integers.
No.
Oh,
comparing
an array of
String.
So I'm comparing, so what does a array of nums return?
an array of.
An array.
Yeah, so it returns an array, and then I'm comparing an array with an array. So I want to see if is this array equal to this array?
No.
So what's the problem with that in JavaScript?
It can't compare its elements, right?
Yeah. So the way that JavaScript does it is it compares by reference.
Yeah.
So if I say, is this array equal to this array, it's saying like, is it the same reference? Which means like, is it literally the exact same object? In that case, even though these arrays are, equal from, a certain perspective, they're not the exact same. So JavaScript doesn't like this. So there's a method, obviously, as you might expect, built in to handle this kind of thing. So toStrict equal. So this is going to take care of that. So it'll look at every element and make sure that it's all the same. So this test now passes. So we have this returns an array of 1 and so on. So this is, one test. We probably want to write some more tests with different numbers and just make sure. We could also, there's a whole bunch of methods here. So toStrict equal, for example. Let's look. So 2b was the default that showed up here. There's also toEqual. It recursively checks every field. So toEqual or toStrict equal is to be null, to be undefined. So we can look at the documentation and there's a whole bunch of these methods that are built in. So there's even a not method, so not dot to match, and then you can pass in what is this?
Regex.
Yeah, so this is a regular expression. So there's a whole bunch of stuff depending on what exactly you're doing. You would look at the documentation and see, okay, I want to compare X and Y. Is there a built-in method that will allow me to do that? So here, the error message kind of, it told us what to do, but we, don't always have that luxury. Okay, so this is good. I'm gonna kind of assume we could write a whole bunch more tests along that line. So we have one of our methods done, and now it's testable, and we can be pretty confident that this works now. So we have array of nums. Let's go ahead and write this transformed method. So this one is going to take a single element. So it's actually going to be a number. So, but it's, anyway, we might want to think about naming conventions, but I'm just going to call this n. And then we're basically just going to put in I'm going to copy and paste all this logic. So the core logic is going to be the same, except it's not going to console log, it's just going to return. And because it returns, we can actually examine it and test it. Okay, so this transform function takes an integer and turns it into a string. So now I can go back to our tests. I'm going to copy this and transformed. The transform is going to get a single element, so I'll just test this here. So I don't need this to equal. I think I can just use the regular to be. which is kind of like the most basic comparison or matcher, they call it. So to be is. Okay, so I have to also export this. And let's see. This error I is not defined. So what's the problem?
You never make I anything, you never declare I as anything,
Yeah,
just because you took out the for loop where it declares I as one.
exactly. So I was lazy and I just copy pasted some stuff, but I wasn't really careful. And so what do I need to do to fix this?
You could just put I is equal to 1. Or I is equal to well, it depends on where you are in the loop, I guess.
Anyone else?
Do you have to specify the range I from where it starts to where it ends?
So transformed takes in what is n here?
Input.
Sorry? Can you say that again?
Is it input?
It is an input, but what kind of thing is it? What type is it?
It's going to be an integer.
Yes,
Yeah.
a single integer. So my test says if I give it 3, I should return fizz.
So I is going to equal n.
Yeah,
Right?
exactly. Yeah. So I just make all the i's n's. There's no loop here. It's just a single element. I run my test again. And it fails. Received undefined. So my test is failing. It's expecting blah, 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 received to be expected. And then it's expecting fizz because that's what I told it to expect. But what it actually got, what it received is undefined. So why did it receive undefined?
Because there is no return.
Yeah, exactly. There's no return. So what did I do wrong here?
Put return keyword in front of phase word.
Yeah, so I only returned this first one, and then the others are just kind of floating there. So I need to return all of them. So return here, return here. This is one reason to write tests, right? So it's pretty easy, especially as things get more complicated, to write stuff that has little bugs in it that might not be obvious as you're writing them. But if you have a test that says, at the very least, I want this thing to work, and ideally you have lots more tests with a range of values, and provide scaffolding. So it's like outlining the shape of the function, so you can be pretty sure that what you're writing is correct. Okay, so this transformed works. So this is now testable. Every time I give it a 3, it should return fizz. No matter what else is happening in the world, if I give this function a 3, it will return fizz. So it's a pure function and it's testable. Okay. So now we have transformed array of nums. Let's do fizz buzz array. So we get this array of nums. So at some point, we're going to have to tie all these things together, right? So we're kind of writing isolated functions. At some point, we're going to have to tie them all together. But this, this buzz array is going to take this array of numbers, and then it's going to return a new array of strings, which is going to have the 1, 2 fizz and so on. So I'm gonna write this function here. So instead of array of nums, it's going to be fizzbuzz array, and this is going to take in an array of nums. So I guess I could just use the same name here. And there's a few different ways we could do this. I'm going to use, has anyone heard of map?
Yeah, dot map.
Yeah. So can you tell me about the map method on arrays?
Forms a function, right?
Uh,
So you can specify what you want it
yeah,
to
so
do.
technically it's a method on array, but yeah, it's a function.
Yeah.
So does anyone know what map does?
Well, it is a iterator. It iterates through the array, and then you take, for each element, you can transform the element.
Exactly. Yeah. So what it does is you start with an array, and it's kind of like a for loop. You start with an array, and it will loop over every element in the array and execute a function on every single element, and it will return that transformed array, the new array. So if I have an, I have like 1, 2, 3 dot map, and map is what kind of method or function is it?
High order.
Yeah. So it takes a function, right? So it's a method that takes the function. And typically we pass an arrow function. We could pass like a full-fledged function in here, but for brevity's sake, so we'll usually do like, so this will be a number. This is going to represent the number. This is the input parameter, and then an arrow, and then we want to add 1. So n
Plus 1.
1. So this is going to return a new array, a brand new array, which is going to be 2, 3, 4. So map is going to execute this function on every single element. So it's going to say, okay, first element, number 1. So number 1 is going to be n, and it's going to return n plus 1. So it's going to return 2. And then it's going to go to number 2, and so 2 is going to be n, and so 2 plus 1 is 3, so it's going to be 2, 3, 4. And this is going to return, it's not modifying this array, it's returning a brand new array. So it's a pure function, right? At least, potentially pure, right? Because it's returning it's not modifying anything in place. It's returning a brand new function. So let's go ahead and do that. So we're going to return. So array of nums. We want to take that. We want to map over it, and we want to apply. Which function do we want to run on every element of this array of numbers?
We're going to do transformed.
Yeah. So we're going to run this transform function. So map, and this is going to be a number, and we're going to take that number and we're going to run this transformed, and we're going to pass it that number. There's a slightly shorter way of doing that, writing this, but we're not going to worry about that right now. Okay. So that should, let's write a test that, so make sure that that does what we want it to do. All right, so the fizzbuzz array, I think we're actually, so we're talking about something that returns an array, right? So we're probably gonna have to use this toStrict equal. So I'm gonna start with this test as the base, and then fizzbuzz array. So fizzbuzz array is going to take 1, 2, 3, and then what should this equal?
1, 2 fizz.
Is it just 1, 2?
1, 2 fizz, right?
Yeah. What type are we? Yeah. Yeah. So it's actually gonna be the string 1, the string 2, and the string fizz.
Gotcha.
Not a great test name, but it rolls it for now. So if I run the test again, I can see that this test passes. So I have 3 passed tests, and I can see each one of them here. So fizzbuzz array returns correct array. So again, I would not want to just have one test. I would want, to test a few more different things and so on. But this is kind of a stand-in for several similar tests. Okay, so it looks like we can start with a number. We can generate an array of numbers, and then we can transform that array of numbers into our array of fizzbuzz stuff. So then the next step is to take this fizzbuzz array and turn it into a string. So const fizzbuzz array to string. And that is going to take the fizzbuzz array and it's going to return a string. So how do I take the array of like strings 1, 2 fizz and turn it into just a string?
Join.
Yeah. Yep. So we can do fizzbuzz array dot join, and we could choose the delimiter. We'll just make it a space for the sake of simplicity. So pretty simple. So let's go to our tests, and our output is going to be a string. So I think we can just use the ordinary 2b. So let me export this first, and then import it. And okay, so then I got fizzbuzz array to string. I'm going to copy this thing. And we just want this to be 1 space 2 space fizz. So being lazy with the test names, but there you go. So running the test again. So we should have 4. Okay, so 3 passed, 1 failed. Let's look at the failed test. So what's the problem? It's expecting 1, 2 fizz, and what is it getting?
Undefined.
Okay. So why is it getting undefined?
You're not returning anything?
Yep. So you have to return the value that we're creating. And then we run the test. And it passes. So of course, we would want to write a few similar kind of tests to this, but that's a stand-in. So now we've basically increased the testing surface of our fizzbuzz. So pretty much everything is testable now, right? We have fairly short methods that we can test easily that do just one thing. So the very last part is we actually want to display this. So I'm going to call this fizzbuzz. This is basically going to tie everything together and then console log the output. So const fizzbuzz. So what is fizzbuzz going to take?
All those functions.
Yeah. So this is like if we were writing a library or something like that, fizzbuzz would be the external facing API. So this would be an external method that if I were importing this library, I would use this. And fizzbuzz internally depends on all these other functions. There's not really a way to mark that. And again, other languages are a little bit more explicit about this kind of thing, but it's fine. So this is the function that you as the user would call, and then this function internally will use all these other smaller methods. Okay, so fizzbuzz is going to take a number, and this is going to end up logging everything. So first we're going to have to call array of nums. We're going to call array of nums with num, and then whatever that is. So there's a couple ways we could do this. I'll show you kind of two different ways. So array of nums, and then that is going to get called by fizzbuzz array. And then fizzbuzz array. So this one, fizzbuzz array is string. And then what I want to do is console log that string. So I could just wrap all of that. Let's see. What's going on? I do something. Did something wonky here with the.
Are you missing one bracket, one curly bracket?
Yeah, I'm not sure what it did. Something autocomplete at some
I think
point.
it's underneath. You need one more bracket, just underneath it.
Let's see. Yeah, still something's wonky. I'm just gonna start over here. Sorry, I don't know what happened. Okay, so I'm gonna console log something. I can start from the other end, I guess. I'm gonna console log fizzbuzz array to string. And that is gonna take fizzbuzz array. And fizzbuzz array takes an array of nums. An array of nums takes that num. So I can try executing that here. I'll just do. So here's the output that we get. So this is, obviously not really great from a readability perspective. Yeah, but that's kind of what's happening. So, we call a function, the result of this function is the input to this other function, which is the input to this function. So someone mentioned monads earlier. So this is not really a monad, but it's in that ballpark where this is like composable. So the output of one thing is the input of something else. So you can kind of chain everything together. So maybe a clear way of doing this would be to start, again, we'll start from the inside out. So and this is meaningful, right? We can assign these all to values, to variables, because they have meaningful values because they're pure functions. FizzBuzz array, and then we'll take our nums. And then we will return finally our console log. So this should do the same thing, right? To get the same output. So 2 different ways of doing that, but so now we have a way of being sure that this actually, so each individual component, each function kind of does exactly what we expect it to do. If there's ever a bug somewhere, if something ever happens, it's much easier to isolate and then fix. So if there's some bug with this join or whatever, or even we want to change this, it's easy to do that. So are there any questions about that?
So just to kind of paraphrase, what you really essentially what you did is you took your FizzBuzz function that did 4 or 5 things and then created that many pure functions to test them, right?
Yeah. So you can't totally eliminate side effects because we actually want to see this on the console, right? But so there's a couple of things we did. One is exactly what you said. We kind of took something that did several things and broke it up into smaller pieces that are more modular and that only do one thing, ideally. And then we also isolated the side effect part of what we were doing. So the side affecting part of what we're doing, which you can't avoid, is now contained just in one method. And we could even isolate this further. So we could put all this stuff in another method so we can test the result of all this stuff kind of stacked together, and then just have one method that all it does is console log a string. Okay. All right, cool. So so the lecture is longer than I would have liked, so that happens on occasion, especially the first week or so, but hopefully will be mercifully shorter in the future. And then they're actually going to pick up towards the end when we start doing more complicated things.